Today we have to start our lesson Semiconductors. Semiconductors. Semiconductors is, say the contribution of semiconductor is 8 marks in your CBSE exams and 2 objective questions in your JEE Mains. So basically the semiconductor lesson is subdivided into 3 parts. The first one is solids and second one is semiconductor devices and the third one is logic gates. In this particular lesson, we have to study about the solids. Solids are basically here in our physics. We have to study about the conductors, insulators, and semiconductor. And the lesson is all about semiconductors. So we have to more emphasis over semiconductor area. Basically, the questions of solid, the contribution of solid is 2 marks in your CBSE, and this is for 4 marks, and this is for the 2 marks. And one questions may be asked from solids or logic gates, and one questions exactly will ask from the semiconductor devices. So let's start with the solids. Solids. In chemistry, we study about the solid, the types of the solid, like the amorphous solids and crystalline solids, and their molecular and atomic arrangements, and how they changes their shapes with rise in temperature and fall in temperature. But here in physics, we have to study about their conducting and insulating natures. So the conductors, basically, in general, in common words, we have studied in lower classes, like the conductors are those materials who can conduct heat and electricity. But here in higher classes, we study conductors in terms of presence of free electrons and energy gap. In conductors, basically free electrons are available. Like all metals are conductors, like copper, iron, and silver. These all are conductors. In general, all metals are conductors, and all available elements in our periodic table can be subdivided into 3 categories, that are the conductors, insulators, and semiconductors. Normally insulators are non-metals and semiconductors are group 14 elements. Majority are silicon and germanium. Here conductors are coppers, iron, ferrous, and silver. So we have to study about how we can distinguish between conductors, semiconductors, and insulator in terms of energy gap or the presence of free electrons. In conductors, the metals has the electronic arrangements, or any elements have electronic arrangement like this. Electron situated at the center of the atom, proton or nucleus is situated at the center of the atom, an electron revolve around the nucleus in a circular path in anti-clockwise direction. That you are very well aware. This is the first cell, second cell, and third cell. The outermost cell and last cell is called valence cell. Valence cell or valence band in terms of the conductors, insulator. Or there above the valence band, after few energy levels, there is a other band that is called conduction band. When electrons jumps from the valence band to conduction band, the metal can conduct electricity. So for the metals or conductors, the energy gap between conductors and between valence band and conduction band is very low. It is about less than 1 electron volt. So the key point is the energy gap between valence band and conduction band for metal is less than 1 electron volt. or the valence band and conduction band is very close to each other or merge with each other when small amount of potential difference or energy is applied, the electrons can easily jump from valence band to conduction band, and its numerical value is less than 1 electron volt. And for insulators, insulators were those like carbon or some other metals like oxygen. These all are considered as the non-metals or insulators, or rubber, glass and lead and other elements all are the insulators. In terms of the energy gap, the valence band and conduction band are far away from each other, and the energy gap is more than 1 electron volt. So whatever the energy or potential difference we applied across the insulators, the electron cannot be jumped from the valence band to conduction band, so they cannot conduct electricity. So here we are aware about the conductors and insulators in terms of the energy gap or energy band theory. So our main concern is here. So our main concern is there is semiconductors. First of all, you should know silicon and germanium are two natural occurring semiconductors, and their energy gap is moderate like 1 electron volt. So energy gap between semiconductor is moderate, that is about 1 electron volt. For silicon it is 1.1 electron volt, and for germanium it is 0.72 electron volt. The energy gap between silicon is 1.1 electron volt, and for germanium is 0.72 electron volt. And in general we can write it about 1 electron volt. So at room temperature like 25 degrees centigrade or 298 Kelvin, they can act as a conductor. But at 0 degree temperature or 0 degree Kelvin, they act as a insulators. So it is the different case from the conductors. The conductivity of conductor is decreased with rise in temperature, whereas in case of the semiconductor, the conductivity of semiconductor will increase with rise in temperature. The conductivity of semiconductor will increase with rise in temperature, and their expression is T raised to power 3 by 2. How much temperature will be applied, the conductivity will increase. Conductivity will increase, it means we know the conductivity is inversely proportional to the resistance. It means the resistance of the semiconductor will decrease with rise in temperature and conductivity will increase. And it is opposite to that of the conductors. So here you are aware about what is semiconductor. We can say simply the semiconductors are those materials who lie between conductors, or who lies between conductors and insulator. Their conductivity is moderate, or their resistance is also moderate, that is higher than insulators and lower than conductors. In terms of their values, the energy gap lies between 1 electron volt. And for silicon it is 1.1 electron volt, and for germanium it is 0.72 electron volt. Or the other characteristic is with rise in temperature, the conductivity of semiconductor will increase with T raised to power 3 by 2, and here T should be taken at Kelvin scale. So the other thing is natural occurring semiconductor, silicon and germanium, is called intrinsic type semiconductor. Intrinsic type semiconductor, and their conductivity is very low. To increase the conductivity of semiconductor, we have to do a process called doping of a semiconductor. Doping of a semiconductor is what? We have to add some impurities, but the ratio of impurity is very low, like 1 in 10 raised to power 5 or 10 raised to power 6. Like 1 million or 1 million से ज़्यादा electrons we have to add 1 in 1 million and more atoms of silicon or germanium has to be taken, and we have to add only 1 atom of the impurities. So after adding the impurity to the semiconductor, the conductivity of semiconductor will increase tremendously. By a small amount of addition of impurities can increase largely the conductivity of a semiconductor. And doping can be done by two ways. Semiconductors are generally of group 14 elements, so that they have the 4 electrons in their outermost shell. So when we add impurities of pentavalency like phosphorus, antimony or arsenic, like when we add the pentavalency impurities, it will become the n-type semiconductor. N-type semiconductor, how? See, the arrangements of silicon Silicon has 4 electrons in its outermost shell, and all 4 electrons are combined with 4 different silicon atoms by single bond. When we replace one silicon atom by phosphorus, the 4 electrons of phosphorus will combine with the 4 different atoms of silicon. But one extra electron will remain, because phosphorus has 5 electrons in outermost shell and silicon has 4 electrons in its outermost shell. So these n extra electron will increase the current carrier elements in the semiconductor. So here the n extra electron or negative charge is act as a current carrier element, so it is called n type of semiconductor. N for negative, and it is called n type semiconductor. How we can obtain the n type semiconductor? When natural occurring semiconductor, silicon or germanium, is doped with pentavalent elements like phosphorus, antimony or arsenic, then we get the n-type semiconductor. And in n-type semiconductor, there is the excesses of electron. The number of electrons is much greater than number of holes. So here electron are the majority carrier, so they will act as a current carrier elements. And see here, the overall semiconductor does not require any kind of charge. The neutrality of semiconductor will be maintained whether we will dope or do not dope. There is no overall charge of the semiconductor. And for p-type semiconductor, we have to dope the natural occurring semiconductor, silicon or germanium, with trivalent atoms like barium, aluminium, etc. See, again here all 4 bonds of silicon are occupied by neighboring 4 silicon atoms. When you replace one silicon atom by aluminium having trivalency, like it has 3 electrons in outermost shell, all the bonds will be occupied by 3 bonds will be occupied by aluminium of silicon atoms. But an extra electron will be taken from this particular aluminium atom, so there is a vacancy generated called holes. 3 electrons in outermost shell of the aluminium. Aluminium has electronic configuration like 2, 8 and 3. These 3 electrons will be taken for 3 neighboring silicon atoms, but one extra electron will be taken from the inner shells. So the holes will be generated, and holes are in general positively charged, and here the number of holes is much greater than number of electrons. So this particular holes will act as the current carrier elements, and for p-type semiconductor the majority of holes are available. So, and again here the overall silicon atom or p-type semiconductor does not require any kind of charge. So here what we have studied is, let me conclude, what are the conductors, insulators and semiconductors in terms of energy gap and availability of free electrons, and what are the natural occurring semiconductor, that is silicon and germanium, and how the conductivity of a semiconductor can be increased, that is doping, and how n-type and p-type semiconductor is obtained. That's all. Okay.